What is up? Daniel here with the Virtual Robotics Studio, and we're back for the next video in our Swerve series. We have the chassis kind of built mechanically, so it's time to get all of our electrical components in and get the thing wired. But before we start, another special thanks to Argosy for making this all possible, and to our product sponsors, West Coast Products and Cross the Road Electronics. And also thanks to our hosts, Team 302 and Lake Orion High School. All right, we're going to get wiring. Couple notes, though, before we start. First thing is, again, we're just doing this kind of rolling base chassis here, so we don't have any extra components. There's no launcher or arm or gripper or intake or any of those other systems on here. So this is going to be a simplified version of what you'll need to do for the season. That means that we'll be kind of taking the easy way to get this wired up. You might have some extra complexities. We'll try to point those out when we get to them. The other thing is we will try to keep everything legal per first rules last year for wiring. Might make some comments as we go through, but make sure you're checking the rules for wire gauge size, where things can be plugged in to make sure that if anything changes, you're still building it correct. All right, with that said, let's get started. We've got the battery in and the battery wire. And the first places that that's going to connect to is the power distribution hub and our main breaker. So we'll kind of find a place for those. And again, because we have so few things, I think we also just need room for a RoboRio or radio and a couple of small, we need the Pigeon and our CANivore, but we have so much room in here to attach stuff that we don't have to be too careful with where anything goes. So I'm thinking, we'll kind of just put this in the middle, this here. Maybe we'll start by hooking this wire up and seeing where that will reach. So again, the main power will come from the battery. We have one of these pre-made cables, because again, we're just saving time. If you make your own custom cables, go for it. So that's going to hook up. The red side is going to go to the power switch. The black side is going to go directly into our power distribution hub here. So let's go ahead and get that attached. And the red side is also going to go in to the power distribution hub as well. So we'll get that attached too. I will note every time you make a connection with wires, you definitely want to tug on it to make sure it is actually seated and connected. OK, then let's see. So one end of this is going to be here on the main breaker. So let's go ahead and unscrew that and drop that on. And we'll come back through and tighten everything up all the way after we're happy with where stuff is mounted. Got to get that washer off of there. All right, and do all of that. All right, so we kind of have this. That seems reasonable. I think we could plug this in. Yeah, so somewhere around there seems pretty good for both of these items. Let's go ahead and unplug this. So I think for the power distribution hub, I've just got some big pieces of Velcro that we'll rely on. So I think right about here was good. So we'll just stick that down. I think on actual robots, I would still be comfortable doing this as long as it's a big piece of Velcro. Because this is really stuck on there. But of course, if you want to be extra careful, you could do bolts on the holes on the side. I don't know why. The power switch, though, I feel like just because the big wires really pull on it a lot, I like to actually bolt that one down. So let's find a good spot for that. This seems all right. And we can make a couple quick marks here. And that's where we'll drill a couple holes. OK, I think I'm going to use 1/4-inch bolts. So I got a 1/4-inch drill bit here. See, we want to make sure we don't drill into the table. So let me just grab a piece of wood, and we'll slide it underneath there. All right. And here we go. should be pretty good. And let's see here. I think I'm going to run the bolts up from the bottom because I think they're a little bit too long. So we'll kind of tip this up. There's one of them. And again, I'll do a washer on the bolt here. And you know what? I can probably use this piece of wood to tip it up a little bit. Okay. Those started. Then get the Allen wrench on the bottom here. I will mention, of course, the power switch. On your competition robot, there's some rules about accessibility, so you can get to it in case of an emergency. This is easy to get to for us because nothing is going on top. But of course, if there was a huge structure being built up here on top of the robot, maybe that's not the best place for it. Maybe you'd have to move it somewhere else. But for us, it's going to be fine. And now that we know where this is going, let's go ahead and tighten the bolts down on our wires here. And I will say, just as an aside, these being loose is one of the biggest causes of robots disconnecting during a match. So make sure they're nice and tight. Although I have had people over tighten it and break the stems off. So I guess you got to find a good balance there. All right. We'll say too, I've had inspectors in the past have us add extra electrical tape on these to cover them up even more. So be aware that might be a thing. Okay, that's connected. We can even plug it in and turn it on. We should get lights on our power distribution hub. Perfect. So this is set. Our main power to the power distribution hub is set. Let's grab a few more components and get started on them. Okay. So now we have the rest of our control system. So we have the RoboRio, of course. That's going to need to go somewhere. Maybe we'll put that somewhere on this side. We have the CANivore as well. The CANivore is going to connect to the RoboRio with the USB cable. And then we're also going to hook up power and the start of our CAN chain, our CAN network here. So we'll need to probably connect to one of the wires from this module. So this seems like a reasonable spot for it. Then we've got the radio. We've got one of the new radios for 2025. So this, I think they want it mounted directly to something that can sink some heat. So we'll put it on maybe the outside of our frame here. I guess I like this side. This side seems good because, again, this has to get over to one of these. There we go. The Rio wire is going to come over to here with an Ethernet cable. So somewhere there seems good. And then I think the only other thing we have to attach here is our Pigeon. And the Pigeon can attach kind of anywhere. I think in the documentation it says if it's close to the center of rotation or closer to the center of rotation, that's a little bit better. So somewhere around here puts it really close to the center of our robot. So I think that's a pretty good spot. So yeah, I'm sold. Let's go ahead and start attaching stuff. I'm going to just Velcro the RoboRio down. It's pretty light, so I think that works out well. Give myself enough room to use some of these things here. Some of the ports on the hub. The CANivore as well. We'll go ahead and Velcro that on. Let's see, maybe this way? This way. That seems all right. All right. And the radio, I think we'll do zip ties, which does mean we're going to have to drill a couple holes. So let's switch up to, let me grab I think the zip ties I have are probably about 3/16 will work. I think the 1/4" hole is maybe fine, maybe a little too big. And I guess what we're going to do is I'll run it through these beams. I don't want to go around the front of the robot, so I'll go down through the holes. So I'll just try to line this up with a couple of the holes here. So maybe this one, and looks like it's in between these two. So we could do this one. Yeah, that seems pretty good. And then that means we need a hole like here and a hole like right here. Okay, let me, again, not drill into the table. And all right. I think for this, we're going to want it propped up a little higher. And let's get some zip ties for it. All right, so if we go up, you know what? I should have checked. That is a hole with a rivet in it. So I'll move over one, and we'll see if we can salvage the holes on the bottom. Okay. One looks all right. Okay, and the good news is that one did not have a rivet in it. But there are these little notches on the radio frame that you want to make sure your zip ties are running through. That'll stop it from sliding too far side to side. All right, that looks good. Hopefully we can get to those wire ports, but if not, we can always cut the zip ties and do it again. All right, can lower it back down. Okay, then the last one is the Pigeon. So this is our IMU, or inertial measurement unit. This I don't want to Velcro on, because any sort of like extra wiggle that it does is going to potentially make its readings less accurate. So this is like, it's going to measure the rotation of our robot, the angle that our robot's turned to. And if the mount moves a little bit, that could throw us off by a couple degrees, which would affect our accuracy while driving. So this one I'm definitely going to bolt down. Let's grab some bolts for that. And a smaller drill bit. I think these are M3 bolts that I'm going to be using. But we can just check that they fit nicely in there. And we said we want it about here. Now it doesn't really matter which orientation this way it's mounted. There is a calibration process that we're going to do later, which will adjust for any misangling this, right? So I think it'll have us tip the robot up on its side like this, and that will measure which axis is facing forward. So in this case, I'm going to do my best to keep it because I like it to be nice and square. But if I'm off a little bit, I just know that it doesn't really matter. And I'm going to do, I guess X is facing towards the battery. And I think I said the battery is going to be forward on this robot. Let me move it out just a little bit to make sure we are OK to use those ports. And I'm just going to go ahead and drill one hole. And I think we'll go ahead and bolt this one in. And then move on to the other one. So I do have a little washer for underneath. Let's go ahead and tip it up. I guess we'll tip it up this way. But making sure not to crush any of my wires. OK, so we'll start with the bolt and a washer. And then you can drop that on there. And maybe another washer on the top, too. Why not? All right, we'll go back and tighten that all the way in a second. And now I'm trying to just eyeball that it's as square to the frame as it can be. And then we'll do the other hole. OK, and then we'll do the same thing. Get another bolt and another washer. Yeah, maybe I'll just use this. See if I can reach. Yeah, no. I can't tell at all where that hole is, so let's go ahead and tip it back up. And there we go. Washer, nut on top. All right, and then, let me see here. Let's get the Allen wrench for these. Oops. That was one too small. OK, and need a little wrench to hold the top. I don't know if my smallest wrench gets that small. Oh, yep, that's the one. Oh, no, that's not the one. It's too big. So that's fine. We'll hold it with a pair of pliers. This doesn't need to be super duper tight just because it's holding something small on. So you can almost just do it by holding it with your fingers, but I will just grab onto that, tighten it up a little bit. All right. Looks good. Last thing we can do, I guess, right away is we can take the USB cable and plug that into the CAN coder. Or the CANivore, sorry, and then plug that into one of the USB ports on our RoboRio here. All right, and now I think everything is mounted in the robot. So now we just got to go through and connect all the wires. So give me a second. Let me get rid of all these tools and drills and stuff, and we'll come back with the wiring stuff and start attaching things. OK, so there are kind of two different things that we're wiring here. One is going to be power to all the devices. That's going to be the red and black wires. And then the second thing we're going to wire is our CAN wires, which stands for Control Area Network. So we're going to kind of ignore the yellow and green wires first and focus on the red and black ones. Now, this is what we talked about when we were attaching the kind of the cables that came in the kit, like I know that these wires can all reach basically anywhere on the robot, but certainly the center of the robot for our power stuff, to our PDH. So because these can kind of just reach, that's why we don't have any connectors. We're just going to wire them in directly. So the ones that look like they're the, let's see, hardest to get there are, I guess this is the front, because I said the battery is going to be the front of the robot. So this one looks like it's the shortest. So those are going to have to go in probably this first slot here. And we'll work from that. OK. But basically, we'll open the levers up. And basically, all we have to do is strip the wires, stick them in, and close the levers. So go ahead and do that. OK, and with these, you don't really have to twist it. If you have some wires that are sticking out, you can help them stay straight. But it should just go straight in, and you can lower it down. Give it that tug test. And if you see any wires coming out of the housing here, then you stripped too much, and you should redo it. But I like about 3/8 of an inch, maybe a touch more, to be a pretty good length here. OK, there we go. Next up. You know, these ones we probably could cut down, but I think I'm not going to for this setup. And again, I think also if you're doing a test setup for your robot this way, you may not want to, like you may want to leave some of the wires a little bit long, because then when you go to put it on your actual robot, you don't need to get brand new wires, because maybe you didn't cut them enough for them to fit. Or maybe you're going to need to cut them more. But it just seems like for me, I'm going to keep everything as long as I can, so that gives me the most freedom to do other things with it in the future. All right, so those are in. I guess we'll do all 8 of our drive motors here, and then we'll sort of route the wires and clean them up. But I do kind of like, we might as well move over and just keep going right next to the ones that are there. Of course, these wires are going to be way long, but that's OK. Strip those two. The other biggest thing that you want to watch out for here is just make sure you have your wires are going into the same port. Because you can very easily, pick 2 in the middle and end up having one from, like, say, 16 and one from 17 instead of having both of the 17 ones. All right, keep going. These two. Give it a tug. Looks good. Other side. All right, so this side, the black one goes in first. It is opposite of the first side we worked on. Good. Right, and of course, the other thing you have to be extra careful of is that your two wires that are getting plugged in are from the same motor. You don't want to have like one from the steering motor and one from the propulsion motor. Oops. Looks good. And our last module here. thing. There we go. All right. So you can go back through now and sort of bundle up these wires in a way that is going to keep them out of the way of stuff. Okay, and I guess let's grab that wood block again. And there are a few different ways. There are like some zip tie anchors that you can get to plug in. I think the easiest way, though, is since it's wood, we don't have to worry about aluminum shavings or stuff getting in the electronics, nothing conductive there. So we can just kind of drill where we want and then just add some zip ties as we go. So maybe do one around here. Okay, to tip it up. And down from one, and then back up the other. All right, so just like that, we'll probably do another one, somewhere over here, just to keep it going nice and smooth. And then we'll repeat the same for all of the other corners. All right, so we are done fastening all the wires down. We got it. I think it's always nice if you can keep the wires from bunching up so you can see which wire goes where and trace them really easily. Obviously, on a test platform, sometimes that's less important because it's temporary. Sometimes it's more important because you're trying to figure stuff out and you don't want to troubleshoot like wires going to the wrong place. You want to troubleshoot getting your Swerve up and running. All right, we have some more power wires to run. We can take the Pigeon wires, and these ones I especially kind of don't want to cut because they're attached inside the case. So we'll just have some extra wires here, but I'm just going to go right to one of the fuse ports over here. So let's go right into, I guess we'll go right into 20. And with these, sometimes you can just push them in, and sometimes you have to push down on the button to help you out. That one just went right in, no problem. Help that one out a little bit. All right, and make sure you give them the tug test. All right, that's wired. We will tidy that cable up in a little bit. All right, next up is we have the CANivore, the RoboRio, and the radio that all still need power. So I'm going to do, I think this is 22 gauge wire. I think you can use 22 gauge wire to any of the 10 amp or less fuse ports. And that is where I'm going to hook up the RoboRio. So on the RoboRio, there's this little connector here that you can unscrew, and it comes out. And then on the other side, there's some screws that you can go in to connect the wire. So turning this screw will sort of clamp down in that spot. And then on this, there's a V and a C. So C is for common or our ground wire. That's going to be black. And then V is for our voltage in. So let's start with, we'll just start with this wire. And just going to strip a bit of it. And we're going to check when it goes into the V and C ports, same thing as when we were kind of doing the other one. If there's any extra wire sticking out, like for me, I've got just a little bit of wire showing. So I probably stripped a little bit too much. We're going to just trim those down a tiny bit. And then we'll look again. All right, so common and V. So when I slide those in now, yeah, now I don't see any wire poking out. Now it's just the insulation. So we'll be ready to go ahead and screw those wires in. And you kind of want to make this as tight as you can. We definitely do not want these wires coming out. So give them a tug test. Make sure when you do these tug tests too, you do it individually. Like it's really easy to grab both cables here and pull. But if one cable's in tight and the other one's loose, you might not catch that. So make sure you give each of them an individual little tug. All right, that looks good. So we can go back over to our RoboRio here, plug those wires back into their port. They go this way. It only fits one way, so if you're trying to plug it in and it doesn't go, spin it around. But the wires are towards the USB connector and all the other plugs. And the V and C is towards the outside of the case. So we'll screw that in. And these wires are also going to come around. So eventually we're going to probably do something like this. We'll come around underneath here. And then they are also going to pop up into like number 21. So I think we want to cut somewhere around here. And we might end up trimming that just a little bit more, but it's going to be easier to work with now. And I would suggest if you want everything to be super neat, you should like sort of strain relieve the wire as you go, and then you'll be sure that you sort of have the amount that you want when you get to the end. This feels pretty good though, so let's go ahead and strip those wires, and we're going to go, I guess we'll go into the fuse port, what is that, 21? There we go. These ones aren't going, so I'm going to push down to help them out. Looks good. And looks good. All right, so something like that. When all is said and done, we'll have a little bit of extra at each end. Cool. All right, RoboRio is done. Let's move on to, I guess we'll move on to the CANivore over here. So this is going to sort of be the same. And this is cool because we just Velcroed this, so I can take it off to look at the ends. But we have, on the way in, it's can low green, can high yellow. And then we have voltage plus and voltage minus, so red and blue. So we're going to do the V plus and V minus spots for this one. So same thing, let's just grab some more of that same wire because we're going to run this to the last fuse port, which is 22. I guess it's not the last one, there's the switchable one. Strip some of this wire again. All right, and now we're going back to the CANivore. And this works the same way as the other ports. If we're lucky, you can just push it in, but usually that works better. Well, nope, that's fine. It went. Except I put it in the wrong one. So to take it out, we just push down and it pops out. All right. So R goes into the one that says R. Feels good. And then this one next to it. And that one, let me just make sure that's in all the way. There we go. All right, those are both good. So let's stick this one back the way we had it. I think we had it this way, which, sure, seems fine. And let me unplug that for a second. So this is basically going to go over and join our other wire here, because they're going to the same basic spot. So probably we need about that much. So clip that. Got it under the power wires. And yep, let's strip these. One's good, and the red one, also good. All right, perfect. All right, next up, we have our, I guess we'll do the radio power next. And that, I think, more or less out of fuse ports over here. So for that, we're just gonna go into the power distribution hub here. And I think you can use the 22 gauge wire or thinner gauge wire if you have like a very small breaker, 5 amp breaker or so. I think I only have 20 amp breakers, so I think that means I'm supposed to use 18 gauge wire. And so that's what we're going to do. So I'll take some of this 18 gauge. And this wire is stuck together, so we got to start tearing it apart. There we go. Okay, and on the radio, there are two more of the same kind of push connectors for 12 volt. And they're kind of the way I mounted it. They're on this side, but it doesn't really matter which way you mounted it. So we'll go ahead and strip this wire for that. All right, and looks like the bottom one is negative, or the black wire. So push that in, tug. Oh, that one came out. Okay, we gotta try again. And that is why you do the tug test. That actually felt pretty good when it went in. Maybe I will hope it out, make sure it gets all the way in there. There we go. That one's not going anywhere. And then the red wire on top here. Also good. Okay, looks good. And these wires are just going to go kind of straight down and then straight back up into here. So that is basically all we need. Cut that. And then we'll strip this end to go into our fuse panel, breaker panel, technically, I guess, breaker and fuse panel. All right, power distribution hub. And I'll just do it right on the end here. Tug on that, looks good. And we're just looking at doing something like that. That's perfect. Okay. And finally, we have the power from all of our CAN coders. So each module has a CAN coder that needs power to run it. So these, I think the easiest thing to do with these is if I bring them down, this is what I was talking about when we kind of decided the direction to mount the CAN coder on here, is that I think this direction has the wires naturally going in towards the center of the robot. And down here, there's this standoff, which is like, I think I can just take all of these wires, run them down, and just get a zip tie right there to hold them, out of the way. It's not going to hit any gears. It's relatively protected, and then we can continue routing this wire in. So let's actually go ahead and do that. I'll put the red wire. I'll try to put the red wire towards the bottom here. Get a little zip tie. Okay, that looks pretty good. All right, then this wire, we have to route. We can do this a bunch of different ways. We can wire each one into its own port on the power distribution hub. But also, these don't use very much power, so we are allowed to take all of them, bundle them up, and then plug them into just one port. But to do that, you can't have 4 different wires going into the power distribution hub. It has to be one wire going in. But if we use a little place where we connect them all together and then have one wire coming out from that, it works. So I think what we're going to do is we are going to have to add connectors and wire to all of these sensors. And let's see. Yeah, I think it makes more sense to take them all to the same spot and plug them all in at the same spot. So let's see. Which way do we want to, where do we want to end up? On this side, maybe? We'll go next to the radio. That seems good. OK. So for these, I guess we'll continue using the 22 gauge wire, because that looks like what is coming out of them. And we just have to find the appropriate circuit breaker when all is said and done. And we'll just strip these wires. And then you get a choice. So there are a number of different ways you can use to connect these wires together. You can, of course, just solder them together and use heat shrink. That is good. That's permanent, of course, which means if you're going to replace the CAN coder, you'll have to cut the wires and resolder. So sometimes that's not great. Soldering, though, is typically less prone to failure than some of the other connection methods. You can get a variety of different connectors that will go on there. The connector that I'm going to use for this one is, and there's a few different styles. We have these ones, which I think came from West Coast products. And these are just lever nuts. So basically the same thing as on the power distribution hub, but you lift the levers up. And whatever 2 wires we put in here will be connected together. So if I put a black wire on one side and the black wire from my sensor into the other side, now those wires are connected together. And I really like these lever nuts. I think the other type, or the brand name, is the Wago ones. So these are also work the same way. Just lift the levers up, put a red wire on each side, and they are connected together. Now, the one thing to worry about with these is if we attach these wires somewhere like this, and these were just kind of bouncing around a lot, there is the possibility that things could work themselves loose. So a lot of times with these lever nuts, you don't necessarily want to strap down on the lever nut itself, because then you can't use it. But I probably will want to try to get a zip tie somewhere pretty close by so that they're supported and they can't really move a lot. You just don't want these to be too free to move around. But I have not had a failure with these on any of the robots I've used. OK, so that's good. We've got this red wire then. So this is going to basically sit here somewhere. This red wire then has to get all the way around everything over to, well, maybe we'll do this side. That seems somewhat reasonable. So what path do we want to take? Maybe this way. So let's do something like this. We're going to probably cut this shorter in a little bit once we have all 4 of them going. All right, this one right here, the question is, does this need anything? If we put our little hub right here where we connect everybody together, then this one I think we don't have to add any wires to. So let's go with that. I will add the zip tie here onto the standoff. Cool. All right, those wires are going to come together somewhere over there. Let's do the same thing for this one. Next module's got to go. All right, so this one can sit down somewhere around here, and then we've got to get the rest of the way. So again, more of the same wire. Let's go ahead and strip it. And then we've got more of those connectors. I'll use 2 of the same one this time. So 1 on red. And then we'll jump back in here and get the other red wire attached. Remember to tug test. I cannot stress this enough. And then our other one, do the black wire. Looks good. So basically we'll have something like this right around here. And then this wire needs to get over to there. So somewhere around here, I'm going to cut it a little long again, and we will figure that one out. OK, and then same thing with our third Swerve module over here. I guess this what are we, front left, if the battery's in the front? All right, looks good. And then we need, let's see, maybe this goes this way. Oh, maybe it goes this way. We can run it around the outside. Nah, I want to go towards the middle. Let's go this way. All right, and 2 more of those connectors and the end of my wire here, wherever it is. All right, and we're going to strip the wire. Oh, that one's already stripped. All right, cool. Bonus. Although I think slightly more. All right. So you got these 2, and again, open those levers up. Red wire on one side. We got to get down in here. The red wire on the other side. And then we give both of those a tug. Okay, and then same thing for our 2 black wires. All right, and then those can sit somewhere like that. And then we can route these wires all the way. I guess we'll go this way and this way and try to get over there somewhere. All right, so I'm going to cut it again a little bit long. And we'll sort of pass it under this. I don't know if I want this to go above or below the other wires here. Maybe below. So we're going to go through like that and then end up over here in the same place. All right. So now on this side, we have 4 sets of wires, 1, 2, 3, and 4, coming from each of the modules. And go ahead and strip. Well, I won't strip these because they're all going to get trimmed. But the idea next is, again, I've got one of those. There are lots of options, so you can pick whichever one works for you. You can solder all of the wires together and then have one wire soldered coming out. You can have, there are a bunch of different terminal blocks that you can find. I have a Wago connector, which instead of just having 2 spots in it, it has 5, which means I have 4 wires here coming in, and that's enough to have one more wire then coming out of this to go into the power distribution hub. So it'd be like this is CAN coder 1, CAN coder 2, CAN coder 3, CAN coder 4, and then this will be the 5th wire that will be the single wire to go to the power distribution hub. So I need one of these for red and one of them for black. Okay. But what I'm going to do now is, just so you don't have to sit through watching me make all the wires neat, I'm going to route all these wires together into the same place and get them zip tied up, and then we'll come back and we'll attach these Wago connectors and then get it attached up to the power distribution hub. And we're back. So all of those new wires, even all the other power wires we did, and actually the USB cable I also kind of strapped down. So everything I think is anchored. You can see in all the corner areas we're sort of close to our connectors, but not directly on them. And we've got all of the wires coming together in this corner here. So we have to do that final connection. So these are the 3 CAN coders from other places. The good news about this is, since this is just power, it really doesn't matter which one ends up where. So if they do get mixed up, it's not a big deal until you're trying to figure out why the one won't turn on. But that means we can just go ahead and strip all 6 of these wires. And then we'll be able to go ahead and connect them all together in that one Wago terminal block. There's the last ones. All right, so then we'll take that Wago block with the one with all 5 ports. I'm just going to open them all up before I lean over the robot, and I'll do both of them so they're both opened. All right, and we'll start with the black wires. So I'm going to put one of them in here, give it a tug, and then we're basically going to work our way down all the black wires here. And a tug, next wire, and a tug, next wire, and a tug. Okay, that's good. And nice. It looks like I got my wire lengths pretty close to where it's going to work. All right, that last port is going to be for the wire we have to make to go into the power distribution hub. But before we do that, let's go ahead and do the red wires on top. So I'm basically just going to have them sit right on top of each other, I think, once we're done zip tying them in. All right, red wires. And I'm matching, so the second wire here is paired with the second wire in the black terminal block. It doesn't have to be. It will work regardless of where you put them. But again, for troubleshooting and following stuff down, that's going to be a little better. OK, that's perfect. Then we need one set of wires to come over to here. I will use kind of a leftover from the radio. So these are the bigger 18-gauge wires. Again, it's probably doesn't need to be 18 gauge, but it is nice to go a little bit bigger gauge than each of the sensors had individually, because obviously there's 4 times as much current flowing through them. That said, you'll probably be fine regardless of what you choose. All right, let's go ahead and strip one end of this. And then these are going to go into that last spot on our terminal blocks down here. So the bottom one, the black wire in. Next one, we'll do the red wire. OK, and then these are just going to go I guess they can go right to, say, this one. Because then we can zip tie all of these guys down together. All right, so we'll go to 12. I like 12. Okay, so we'll cut it right about here. And split them apart, strip them. And nope. There we go. And tug on both of them. Looks good. All right, so we got maybe 2 quick zip ties to put in here to hold this all together, and then we will be done with the power wires. Once we get that zip tied in, we'll come back. We'll plug in a battery, make sure everything lights up, kind of troubleshoot that section, and then it's onto the CAN wires. All right, let's go ahead and put the battery in. We've got these nice and secured. The one thing we have to do before we can actually plug it in and turn it on, though, is we have to add our fuses and breakers. So first, I guess we'll start over here at the small ones, 20, 21, and 22, where we are powering our Pigeon, our CANivore, and our RoboRio. And I'm just going to use the 10 amp fuses for those. Just make sure that they are pressed all the way down. And there are little spots you can see where the metal blades are supposed to go in. So make sure that's lined up too. It is possible to sometimes get that off to the side. All right, those look good. And then we need fuses for everything else. So first, all of the steering or propulsion motors are going to be 40 amp breakers. So we'll start with 40 amp breakers. Everywhere there are big wires basically coming in. So for me, that's going to be 19 right here. 18, 17, and 16 on this side. And it doesn't really matter which way you plug these in, but one side is a little bit wider than the other, so I like to plug them in the same way so they look nice. But you can plug them in whichever direction you want. All right, and the other side, I think it's 0, 1, 2, and 3. There we go. All right, and then we have 2 more things to power. One of them is all 4 of the CAN coders, which come together and go into one port on the PDH. And then the other thing is the radio. So I think I have 20 amp breakers for those. So we can see the radio comes over here into 9. And I think there is a recommendation if you are using these, I think these are Snap Action branded breakers. If you're using these, they are a little tall, so you can clip the leads down so they don't stick up. I'm not going to worry too much about that. I might add some tape later. And I'm going to do another one for our CAN coders here. Now the CAN coders, I think we have an 18 gauge wire coming out and then feeding all of the individual CAN coders. So to me, that seems legal, but you may need this breaker to be a lower amperage, and that would be fine. You could probably do a 5 amp breaker here. The CAN coders are not doing more than an amp a piece, so it wouldn't be a problem. But 20 is what I had left over, so that's what I'm going to use. OK, looks good. Let's now go ahead and plug in the battery here. So let me see. Twist this around. There we go. And then we're going to power it up. And when we power it up, we're looking for a couple things. So the first thing is we want to make sure that everything lights up. I guess the first thing is you want to make sure that there's no smoke and there's no fire. That's what you always want to check first. Make sure that everything, there's nothing crazy going, nothing's heating up. Then we're going to check basically every device and make sure every device is lighting up, and we'll know it's getting power that way. All right, let's do it. Power on. All right, so we know the Rev power distribution hub gets power. That happened before. The RoboRio's lighting up. Our CANivore's lighting up. Our Pigeon's lighting up. And then we can look at each of the Swerve modules. And we should see, yeah, there's a faint blinking light on here. This one I can see a little bit better because it's pointing towards me. But you should see a blinking light on the CAN coder. And then down on the motors, we can actually see blinking lights down inside here. So that one's blinking, this one's blinking. So that looks good. And then on the other modules, just checking through, I see lights on all of them. I'll check the CAN coders. It is also very bright in here because we got the studio lights going. So these should be a little bit more obvious for you to see. But all the CAN coders are lit up. And then the last thing we're looking at is the radio, which is going to be a little bit harder to see because it's facing away from the camera. So I'll tip the robot up just so we can see that. And then we're looking down for the radio down here. And we have power lights on the radio as well. So that means everything is getting power, which is perfect. We do need one more thing for the radio, though, and that is it does have to get plugged into our RoboRio. So I've got an Ethernet cord. Probably a shorter one would be good. But one of the ports on this radio is labeled Rio, and that is the port I'm going to plug into. It's the one right next to the power wires. And the other end of this is basically just plugging right into the Ethernet port on our RoboRio here. So go ahead and plug that in. And then we'll probably throw some zip ties on that later, but for now, let's move on to our CAN wiring. All right, so turn the robot off, unplug the battery, because we're going to go back to doing wiring stuff. I'll actually take the battery out so it's not in my way. And now, let's talk about CAN wiring. So the way that the CAN network works is basically every device gets connected. And there are a few different ways you can actually connect this, but the most recommended way, and especially for the CAN bus that's going to be on our CANivore, is that we want to do a chain of devices. In theory, there is a way to do a different, what they call topology, where you could have a bunch of devices connected and then a little branch going out to another device. Sometimes that will simplify your wiring, but if your branches are too long, if your overall CAN length is too long, you can run into problems with that. So the absolute strongly recommended way of doing the CANivore, especially as CAN network, is to go from one device to the next, to the next, to the next, to the next in a chain. And then in the CANivore itself, it has what we call a terminating resistor. So you need a 120 ohm resistor on either end. So if you imagine, we'll have one long section of yellow wire, one long section of green wire, and basically it'll go from one motor to the next motor, to the sensor, to the other sensor, to the other motor, to the other motor. And on each end of this wire that everything is connected through, we need to put a 120 ohm resistor. This basically stops the signal from coming back. So that shows it where the end of the chain is. So the CANivore has one resistor. We're going to have to add a resistor to the end of the chain, wherever that ends up being. And to make things a little bit more confusing, we actually have to have two CAN networks here, or two CAN buses. So one of them is going to be controlled by the CANivore. That's going to include all of the CTRE stuff. So that's going to have both of the motors and all four of our CAN coders for each Swerve module. Then we also actually need to hook the Rev power distribution hub up to a CAN network as well. So it has some CAN ports here, and those are going to go directly to the CAN ports on our RoboRio. Now, the RoboRio and the power distribution hub both have a terminating resistor. In fact, there's a switch on here that you can turn it on or off, so we're going to leave that on. Now, the reason why we have to do this is because the CANivore runs something called CANFD. It's a faster protocol, so more information can be sent. It allows for faster controls, faster communication, and more data being sent back and forth amongst the devices, which allow for us to do better stuff, more fine-tuned control with it. Now, that only works for some devices, and the power distribution hub is not one of those devices. And I believe the RoboRio is not one of those devices either. But in the rules, it still says you have to hook up the power distribution hub to the RoboRio with CAN wires. I'm pretty sure we could skip those wires on our test platform, and it would be just fine. But we got plenty of wire, and it's not going to take too long, so let's go ahead and do that. So we'll start there. If you find the CAN port on the RoboRio, we are going to basically take our wires, our giant yellow and green wires. And I do recommend sticking with yellow and green for this. I actually don't remember in the rules if it's legal to use other colors. But it's just one of those things where you want to have consistent colors so that you can make sure that you are always connecting the same one to the same one. So everywhere we connect stuff together, it's going to be yellow to the yellow port or yellow to the yellow wire and green to the green ones. All right, so we'll go ahead and try to connect these in here. Let's see if they'll push in for me. Yep. So there goes green, and there goes yellow. Perfect. We'll tug on those. They look good. And this is the shortest little wire run. We just have to jump over to here, but I probably will go under this stuff, probably under that stuff too. But either way, we need about that much wire, so go ahead and cut it there. All right, strip those. And it doesn't really matter which port you use here. You can use either green port and either yellow port. That feels like it's not really pushing in as much as I want, so let's help it out a little bit. All right, and tug on green, tug on yellow, looks good. Perfect. All right, so that's one CAN bus done. That was the easy one. Next one is we are going to have to connect from the CANivore out through all the devices. Since this module is right next to where the CANivore is mounted in the robot, we will go CANivore to this module. And then the way I think that we're going to do is, so if you've noticed, each motor has 2 sets of yellow and green wires coming out. Each of our CAN coders also has 2 sets of yellow and green wires coming out. They're down here now. And then our other motor, also 2 sets. And one of them is for the signal to go into the motor or sensor, and the other one then will take it out and continue that CAN bus along. So basically, I can choose. I'm going to start all the way on the edge, right next to the battery, and I'm just going to attach everything basically going around the robot. I guess that's counterclockwise when viewed from above. And so that means one of these 2 wires is going to go to the CANivore. The other wire is going to connect to one of our CAN coder wires. Then the other CAN coder wire is going to connect to another one of our motor wires. And then the other motor wire is going to then go all the way over to the other Swerve module. And then that Swerve module, same thing. The other wire there will connect to the CAN coder will connect to the other wire or the other motor. That motor will jump over to the other Swerve module, where we'll do the same process. When we get to the last Swerve module, then that last wire that's coming out that will have nothing on it, that wire we will have to attach that 120 ohm terminating resistor to. Now, if you want to preserve your wires as you're going through this, it is OK. And I have tested this. You can use the plugs that are on them. So there are these kind of PWM style plugs where you can line up yellow to yellow, green to green, and plug them in. And when you plug them in, that is a fine connection. That's going to be OK. I would obviously either add a zip tie holding it in or at least tape, because these can come unplugged really easily. But if you have some way of securing them together, that is a solid connection, right? So that is from the motor to the CAN coder. Then we could take the other CAN coder wire and the other motor wire. So this one is our power motor. So we did steering already. This one, or we did power already. So this is the steering one. We could then do the same thing and connect it and go all the way around. That's going to leave you with a bunch of extra cable, which in this case is OK. But there are some points where having too long of a CAN bus could be a problem. So if you also had a tall robot and you had CAN wires that had to go all the way up to the top of the robot and all the way back down, and you have all these other systems, maybe you have an intake that folds out, so you need a decent amount there as well, you could run into problems. So it is nice to trim it. Also, just from a wiring perspective, like having all of this bundled up is a little bit uglier and a little bit harder to maintain. So we're going to go through, we're going to use the other connectors. We're going to use those Wago style connectors, and we're going to just clip these down to the right size that we need as we go. So first wire then, we'll take, it's your choice. It doesn't really matter which end, because again, we're going to clip the ends off. But we'll take one of these wires, and this wire is basically going to go, I guess I'm going to run it underneath here for no other reason than aesthetics. Oh no, it needs to go in between the two power. Okay, I'm getting a little too picky here. All right, so that's going to run around this way, and it is going to plug into our CANivore right here. So we can just clip these wires off. And this is where I was saying, I think when we started, when we attached these wires to our Swerve modules, I was saying you might want to just get plenty of extra yellow and green twisted wire and attach your own ring terminals, screw those into the motors on your own, and then you'll have exactly whatever length you need. So if you need a super long length, you're already all set. Okay, but back in here, let's go ahead and strip these wires. So this is our power motor on our front left module that we're going to connect. And the other cool part about CAN is that it doesn't really matter what order you connect everything to. As long as you do it in a chain, then each device is going to have its own ID and going to be able to kind of communicate that way. So I'm going to actually take the Velcro off so it's easier to get to these plugs here. And we'll stick the green one in. Let me help it a little bit. Oop, okay. Maybe unplugging it made it worse. All right. So this is actually, the second port is the yellow one. So I'm going to do the yellow one first. Looks good. And then the green one. Never want to have the extra wire that sticks out. There we go. All right, we can plug that back in, Velcro that back down. All right, so that was the first connection. The next connection then is from the other motor, or the other wire coming out of that motor, to our CAN coder wire, our choice of which CAN coder wire. And let's see how we could obviously make this very, very short. I think what we want to do though is we're going to have two connections here, so two connectors. And so we probably want to have room to connect them down, maybe down on the board here. So let's look at cutting them maybe here. That seems like that will give me enough. If there's a little bit extra, that's not the end of the world. So yeah, a little more. There we go. All right, and we can strip these. Okay, and one of the things that I didn't mention about the Wago style connectors or lever nut style connectors is they all have a wire size guideline. A lot of times it's printed on the side of them. Sometimes you just have to read it from where you bought it from. But for example, this one is 24 to 12 gauge wire. So this connector will work for anything we have, and that's great. There are some Wago lever nuts that instead of having them side by side like this, they're going opposite directions. So a wire would come in on this side and go out on this side. But a lot of those from Wago don't go small enough to actually attach our CAN wires, which I think are either 22 or 24 gauge. But we do have from, I think we got sent these from West Coast Products. We have these inline ones, and these are dual inline ones, which is great, and they're yellow and green. So if we put something on this side yellow, it's going to connect to this side yellow. Same thing, green to green. So this is going to be a great, easy way for us to connect our CAN wires together and not have any wires going back the wrong way or any other issues. And these will connect small enough gauge wire. So we're going to grab one of those, open those levers up, and yeah, let's put the yellow in the yellow side. This is like legit, no joke, the hardest part of CAN wiring is matching colors. If it doesn't work, the most likely culprit is a wire not connected or a green wire connected to a yellow wire. All right, so that one's in. Let's take one of the wires coming from our CAN coder. So we have the two CAN coder wires that we ran down and zip tied onto that standoff there. So your choice, pick either one. And we're just going to attach that onto the other side here. So we'll trim that down a little bit. And then strip those wires. And then those are just going to go right into the other side. So yellow to the yellow side, tug, and green to the green side. OK, looks good. So there's one of our connectors. We'll probably package that down here somewhere. These ones, too, are cool because you can put a zip tie across the middle, that section in the middle, and then you still can use the levers. So we might actually just run a zip tie to hold this right in place right there. All right, and then we're going to have this one also connected to one. And I think if we put it right next to them, if we put them right next to each other, we can use one zip tie to hold them both down in place, and that'll be kind of cool. So this wire then is going to come in from this side. We'll leave it some slack, but basically around there we can cut it. And strip them, of course. And let's open up all the levers. Okay. Green to green, yellow to yellow. Tug on them. Looks good. Another thing that you might notice is sometimes this doesn't click all the way down. Make sure you push that all the way down so it's secured. It probably doesn't matter, but I think that guarantees or makes it less likely to loosen up. All right, and then from this is our steering motor now. We need one set of these wires to connect to the other side of that connector. And we can trim these pretty short. So we'll cut those. And then strip them. And I do kind of want it to go under these motor wires here. So there we go. Yellow into yellow. And green into green. Looks good. And if these end up zip tied down right there, that's pretty clean. Could probably do a little bit of a better job, but yeah, nothing is the biggest concern with wires. Like, I know if it's pretty, it's nice for a bunch of reasons. It helps you debug issues faster or troubleshoot faster. But the most important thing is just that none of the wires are going to get into the gears or in things that move. That's the most important thing. Same thing, big loops of wires like this on the side of your robot, that's just asking for another robot to come in, grab it, and rip those wires out. So those are the two major concerns in addition to the debugging. All right, so this module is done. Now we have the wire coming across. to our other module is what we have to do next. And these are almost, I mean, this is almost not crazy to just plug them in and maybe tape them up. I guess it's a little long. So we'll go ahead and trim it and add a connector here as well. So these ones I'm going to have attached somewhere. I think I like the idea of doing them in the middle because I have space to, and then it makes the wires a little bit more universal in case they have to move. All right, so something like here maybe we'll cut. Looks good. And for this one, I'll show you if you don't have the yellow and green double like lever nut connectors, we'll go ahead and use the single ones here just to give you an example of how that would work. So I'll grab 2 of those. And again, these are rated down to 24 gauge, so no problem. And we'll pop one of them on for the green side. And then one of them on for the yellow side here. Tug, tug, looks good. Okay, and we want this to get zip tied down somewhere around here. So we want these wires to be somewhere around, I guess like if we turn it this way, maybe we can bring the wires together. So if we're doing that, we want these to go there to about, I don't know, somewhere around here. Might have a little extra. When you're doing this, of course, you can always trim it a second time if you need to. Can't make them longer as easily though, so. There we go. And green to green. Tug, yellow to yellow. And tug. Looks good. All right, so we'll be able to, yeah, that looks fine. In some way, we'll be able to attach that down. All right, now moving on to this corner. We'll rotate the robot a little bit. Actually, maybe we won't rotate the robot. I just want to make sure we don't get confused as to where we are working. Okay, so we'll just move on to this corner now. And we're doing kind of the same thing. Well, we're doing exactly the same thing. So we have this whole module's done. We have the wires coming across to this module. And they're connecting into, this is the power motor for this module. That's the one that's going to make it drive. That second wire coming out of there now, we are going to connect to one of our CANcoder wires. And I guess I didn't plan all the way ahead, but I think there's room here for a couple of these connectors to go in. So that seems good. So this one can be very, very short, and we'll just get it into one of those connectors. Snip that. All right, we'll do yellow and green. And make sure they're closed. Perfect. Okay, then the other side, right, is going to be one of the sets of wires coming from our CANcoder up here, your choice. And again, it doesn't really matter, as long as you're going into a device and then out of the device to the next device, the order doesn't matter. I'm doing what seems like the cleanest order for me in the way that my stuff is mounted and wired. But you could go motor to CANcoder to the next module, and that would be fine too, if that works out better for your wiring. I think the green one is a little short. There we go. Okay, and oops. Yellow into yellow, green into green. Perfect. And that'll sit down like that. Yeah, I'm sold. That seems fine. All right. Then the other CAN coder wire. This one, maybe this one will go off on this side where we have a little bit more room. Maybe somewhere right around there. That seems good. All right, so we'll trim this. Open them levers up. Yellow and green. And the tug test, okay, next up. So if this is going to be here, this can be a very short wire, something like that. All right, and then into the other side. Good, good. All right, and that, yep, that'll sit down there somewhere just fine. Perfect. All right, then next wire. This wire is now going to come across. Let's see, we need two. Across the front here in some way. Maybe we'll dip under all of this stuff. And then somewhere around here, we'll connect them together. So again, that's, you know, we'll cut it somewhere around here. And as you have, of course, figured out, this is not, there's nothing tricky here. It's just a matter of paying attention, being consistent, and not making any mismatches. Which I guess is true for more or less all of wiring in first. All right, let's get the yellow one in and the green one. Okay. And then on this one, we'll trim it again. All right, somewhere that will go. That one probably left it a little long. That's OK. All right, and now the other motor coming from that wire has to connect to the CAN coder again. And let's see. I think we can again put this kind of right towards the edge here. So super short wire on this one. And we go again. Tug on both. All right, CAN coder wire, we're going to be like right there, so also pretty short. Didn't mean to close the green one. Tug and tug. All right, so that looks good. I have that sit somewhere around there. Next up, guess we'll do one more of these somewhere over here. Okay, so somewhere like there. And there's probably a world where you could have this right on, and I don't even hate that. That might even be better if you go right on that standoff for where these connect. That keeps them out of the way too. And that probably will be more helpful if you have more stuff on your robot too, because this keeps it, there's no gears that go anywhere near that standoff, and you're in pretty good shape. But I'll keep going the way I'm going. Since I have all the space kind of on the board here, it's nice to be able to see everything when we're done. That's a little stuck. There we go. Looks good, looks good. All right, and then one of the ones coming from the motor. This time our steering motor. All right, then this wire is going to come out, but instead of going all the way to our other module, to our fourth module, there is one more device that we have to get connected on this CAN bus, and that is our Pigeon, our IMU here. So this is going to come out. And on this one, just because I really don't want to, again, because these wires are attached on the inside, all the ones we've done so far, I guess the CAN coder wires we cut, but like the motor wires, we can access to change them. This one, just because I want to keep it nice and pristine so I can use it again maybe in the future, we'll go ahead and use the actual connectors that are on here for this one. And that will also give you an example of how to do it if you're doing that for temporary sake. I would not probably do it this way on a competition robot. But just make sure we have green to green and yellow to yellow. Okay, and then we will grab some tape afterwards and tape that together. And so yes, in this section, we will have a big bundle of extra wires that we don't really need. All right, then the other one coming out of the Pigeon, we're going to look for the matching connector. Again, make sure, like it's really easy to think you're getting it right, and then when you adjust stuff and you plug it in to get the colors mismatched on these connectors. I think it's definitely easier to miss this one than it is to miss the lever nuts that we were using before. So just double check afterwards, green through, yellow straight through. All right, then we're on our last module, and we're doing basically the same thing we did on the other three modules. So following the wire in, the other wire that's attached to that motor is going to be our first one. And let's see, I guess we are going to probably put these connectors right down there. That seems like a good spot. So, all right, we'll feed this one in. Really doesn't need much. Yellow and green. How many times do you think I've said yellow and green this video? All right. Then one of the CAN coder wires, and that also can be pretty short. yellow, and green. That's one more time. All right, that looks good. Then the other one, so the other CAN coder wire is going to start on this one and then go through to the other side. So same kind of thing, we can trim it. It's a little bit longer than the last one. Yellow one, green one, tug. I don't remember if I tugged on the last one. Let's just double check. Yeah, all right, looks good. Okay, and this is gonna be like here. So we need one of these wires to come in from the motor. That can be pretty short. Tug, tug, looks good. All right, and then this last wire coming out, this is where we need to add our terminating resistor. So I think I've got one right here. This is a 120 ohm resistor. So that's what you want to look for. The wattage doesn't really matter. So mine, you may very well end up with one that's a little smaller than this. This one is just what I had on hand, and this one can handle a little bit higher current, which is not at all required for this. So yeah, you'll probably end up with one that's a little bit smaller in the middle, or you go on Amazon, you order whatever, and you might end up with this. But any 120 ohm resistor will work. And what we want to do with this resistor is basically we're going to put it into the same connector. You could, of course, solder the wires on, do heat shrink and all of that, and that works really well. But in fact, on your competition robot, I might suggest doing it that way. But this is fast, and it's still going to work, and it's not really going to come apart. The issue here is if I push this in all the way, I still have a bunch of wire that doesn't fit inside the housing. So we need to trim it down a little bit. And I'm going to try to trim it down by about the amount I thought was sticking out. So about this much. And you don't want to trim it too much, but the good news is I think it will be hard for you to buy one resistor. So you end up with like a 5-pack, and if you cut one too short, it's not the end of the world. Or a 10-pack or a 100-pack or whatever. All right, so now we can push that in, get it really close to the edge of the connector here. Okay, and I'm going to do a tug test on that, and that looks pretty good. Okay, then on the other end, we'll open it up. And we can choose where we want this to go. So maybe I'll connect that off on the side here. So we need just a short little loop of this wire to go down to that connector. And we'll cut it. And with this one, technically, doesn't matter which color goes where, but I am still going to match the colors. All right, tug test looks good. And that is going to go down there. All right, so that, I think, is all of the CAN devices now hooked up and connected. We are going to go through, add a little bit of tape to the connectors that are just these regular plugs. And I'm going to go ahead and zip tie all of these things down to manage the wires. And then we'll come back, show you how that looks when everything is buttoned up. But we are basically done with the wiring of the robot. All right, we're back. We have everything now strapped down and cable managed, just to show you everything that we just did. So if we take a look at one of the modules we had where we were kind of showing those connectors, right? I just drilled one hole and did a zip tie around the middle of them. They're nice for that because you can still lift them up. You can still maybe get the wires in and out. But if you had to, you can also cut the zip tie and fix it. So we did that. Managed the other side. Basically same thing on all the sides as we did there. And then finally, we got our bundle of wires here. I added some electrical tape, holding those connectors together. And I always leave a little folded over bit so that if I have to take it apart or fix it, it's a lot easier in a hurry. I guess that doesn't matter too much on a practice robot, but it does on a competition robot. And then in this corner, we have the, kind of buried in there, we have the final connector, the end of our CAN bus. And remember, on one side was the resistor, the 120 ohm resistor. And I just put a piece of electrical tape over it so nothing could get in there and get caught up on it. All right, that's basically it. Everything is strapped down. Everything is connected. So one more time, I'm going to try to turn the robot on. And that is the one difference, if you heard the beeps. Now that there is CAN signal going to the motors actually can play sounds. So you'll get some beeps when it turns on. Also, if you look at the CAN coders, instead of just the faint green flashing light that was happening before, we now have red and green alternating because they are getting signal and they are connected to the CAN bus. So check all of those things. And if that's all working good for you, then I'm going to turn this robot off while I keep talking here. Then the other thing I would recommend doing is, because we did a lot of drilling, if you have the wood panel, first of all, if you have an aluminum panel, definitely make sure you clean those shavings out. But because we were drilling and we have these open Swerve modules, you do want to kind of go through and inspect them. Before we get back and power everything up, and actually start controlling the motors, we want to make sure that there's not like big pieces of metal or aluminum or plastic stuck in the modules to where, like, when the wheel goes to rotate, it's going to bind up. So a couple things. First, visually inspect, vacuum it out. Maybe you can blow it out with an air hose. Visually inspect to make sure that there's nothing stuck on any of the gears. And then physically inspect it by, spinning the gear around, seeing if there's any catching points. Spin the wheel around, see if there's any catching points. This one feels nice and smooth. So I think I'm good on this side. You do have to be a little careful, though. If you use compressed air, it can blow the grease off. So also keep an eye on that. If the grease looks like it's completely gone, just add a little bit more. And if you do that, you'll be ready for our next video when we're going to get everything hooked up and get a program running. But before we go, we have to say another special thanks to Argosy for making this all possible. Also, thank you to our product sponsors, Cross the Road Electronics and West Coast Products. And once again, thank you to our hosts here, Lake Orion High School and Team 302.